Just a minute. বলছিলাম একটা confusion হয়েছে। Last we have seen there are very good conclusions from Rutherford, what we have shared me few minutes ago. So now we came to know that there are very much empty places in Rutherford postulate. And our experiment also we came to know there is a small charge is there, small mass is there in the central of an atom. And also we came to know about the existence of electron, proton, and neutron. So all the particles are there. So these things we came to know from Rutherford's experiment. Now the drawbacks we need to see also.
Was a problem that Rutherford did not address in his model. The revolution of the electron in circular orbit is not expected to be stable. Any particle in circular orbit should undergo acceleration. Why did I say that? If an object is moving in circles, which effectively means...
So are you getting this point? So when you are riding a bicycle in a pace and you are moving in a circular pathway, so automatically it will get the acceleration. Yeah, is it not? So someone is throwing a stone from the multi-storied building. So when it will get down to the earth, as it will get the low speed, that is called acceleration. That's the acceleration due to gravity. But when you are moving in a circular path, so any particle in circular motion undergoes acceleration and changes direction continuously. Okay.
Means it should change direction continuously. Because if you get to the chapter on force and laws of motion, you will understand that any object on this planet can either be at rest forever or it can continue in a straight line path forever and ever and ever until and unless it is acted upon by an external force. And to give a name to this law, it is known as Newton's first law of motion. If it has to change its state from a state of rest to a state of motion, or it has to change its direction, or it has to change from a state of motion to a state of rest, it requires a force to do that. Now again, if there is a force applied on a system, it will always cause acceleration.
So this is the major drawback of Rutherford experiment. So according to the electromagnetic theory, what is saying that if it changes particle undergoes accelerated motion, so then it must radiate energy or lose energy continuously. So when you will be in grade 11, you'll have a concept of line spectrum. So this concept of line spectrum has been given by Rutherford. Okay. So now if we apply this electromagnetic theory to the Rutherford's model of an atom, so it will mean that the negatively charged electron revolving around the nucleus with accelerated motion, and will lose their energy continuously by radiation. Thus, the energy of revolving electron will decrease gradually and their speed will also go on decreasing. Thus, the electron, what will happen? The electron will then be attracted more strongly by the whom? By the nucleus, that is the oppositely charged protons, which are present in nucleus. So, due to which they will come more and more close to the nucleus. As a result, what will happen? So ultimately it will fall where? In the center of the atom, that is into the nucleus, by taking a spiral path. So this should make the atom very unstable and hence the atom should collapse. It's like the earth is moving, around the sun, is continuously losing momentum of it. So what will happen? What will happen? We have seen in the Quran Sharif, that in the Qiyamah, what will happen? The sun will be only one hand away from you. Is it not? So can you say this? So it will collapse and it will be more nearer to the sun. And the same thing happened in the Rutherford experiment, that it will actually collapse and it will get attracted by the nucleus. But this does not happen at all. If it is happen, the stability of an atom does not exist. So we know that the electrons do not fall into the nucleus of an atom. Rather, atoms are very stable and do not collapse on their own. So the Rutherford model, however, does not explain the stability of the atom. Are you getting my point?
Yes, sir.
Okay. So now go through this video.
And that is the second law of Newton. And this can actually be mathematically represented as F is equivalent to ma, which effectively means if a body changes direction continuously, then it should accelerate, because to change direction you require force, and if there is force, there is always acceleration. By the way, don't get into this notion that acceleration should always increase the speed of the object. It can also reduce the speed of the object, or it can also change the direction of the object. And such acceleration, where it is reducing the speed of the object, is called deceleration. So negative acceleration is deceleration. And from this, you can understand that any particle in circular orbit should undergo acceleration. During acceleration, as it was observed through experiments, charged particles would start to radiate energy. Thus, the revolving electron would start to radiate energy and finally take a spiral path and fall into a nucleus. And it should look something like this. If I take a single electron, then it is supposed to start somewhere over here and continuously spiral towards the nucleus. And as it does that, it radiates energy and finally fall into the nucleus. And if it were so, the atom should be highly unstable, and hence the matter would not exist in the form that we know. We know that atoms are actually very, very stable. So Rutherford was able to effectively determine that nucleus existed, but he was not able to explain how the electrons moved around the nucleus. So it was up to the next set of scientists to explain this and solve what scientists thought at that time the last remaining puzzle to put the pieces of the atom together.
To keep learning with such engaging videos, download Byju's, the learning app.
Okay. So before moving on, next one topic is that so who has solved this puzzle? Okay. So there has to be someone who can actually solve this puzzle. So can you know the person's name? Can you know? Can you say?
Neil.
Neil.
Neil Bohr.
Yes, Niels Bohr. Right. It's like Muskan is calling Muskan is Niels Bohr mom, and Muskan is calling that Neil. His name is Neil. It's Neil Nitin Mukesh or someone like that. So Neil Bohr. Actually, what happened in the globally, the person is better known as his or her title rather than his nickname. It's like Tendulkar. It's not like Sachin. Sachin Ramesh Tendulkar. Ramesh is his father's name. So I think these things you know. Okay. So now we are focusing something that's in Bohr's principle, what Bohr has told to us. Okay. So let us now move. We have, so the question about this, the problem was about what? The drawbacks of Rutherford model of atom. So now Niels Bohr experiment, what he has told to us. So Niels Bohr and the stability of atom. Okay. Is my screen visible to all?
Yes, sir.
Yes, sir.
Yes, sir.
So what Niels Bohr actually? So these things can come in exam. Okay. So the drawbacks of Rutherford and also the Niels Bohr's explain the stability of an atom, and after the Bohr's model of an atom, that is also very, very important. Before that, let me put out this thing. So what Niels Bohr has said, that the electrons could revolve around the nucleus in only certain orbits. That is, you came to know in your higher grades certain energy levels. And each orbit having a different radius. So the electrons each orbit have a characteristic amount of energy. So the electron which are in orbit close to the nucleus have low energy, and which is while those in orbits far away having higher energy. Okay. Number two, when an electron is revolving in a particular orbit, or particular energy level, around the nucleus, the electron doesn't radiate energy. That is, does not lose energy. Even though it has accelerated motion around the nucleus. Write it down on your copies. Orbits. Yes, thank you. And since the electron do not lose energy when in a revolving, in a circular path or in a orbit, so they do not fall into the nucleus, and hence the atom remains stable. Okay, so the circular path of the orbit around the nucleus where the movement of the electron takes place are also known as energy levels that we have already known. And higher grades you will get to know about more better and more details about these energy levels that will determine that when the electron is there and the electronic configuration is also related to it. You will get to know about the Heisenberg principle and Planck theory also. So before that, so now let us move to the Bohr's model of atom. On the basis of this, rectification of the drawbacks by Rutherford.
Explaining the structure of atoms. However, it was not very appropriate theoretically. And why are we saying so? We know that any charged object which revolves in a circular motion gains acceleration gradually. Similarly, if the electron is moving fast in a circular path, then it will also gain acceleration. And on gaining acceleration, it's bound to liberate energy in some form. Now, if it continuously keeps radiating energy, then ultimately all the energy of the electron will get over and it will fall into the nucleus. This would result in high instability of the atom. But wait a second, all these things do not happen in an atom. And how do we know this? Because in nature, all the atoms are stable. That means the hypothesis put forth by Rutherford was also incorrect? Not really. The hypothesis just needed slight modifications. These were made by the next legendary scientist in our list called Niels Bohr. He made a few additional explanations to describe the atomic structure. The postulates put forward by Niels Bohr were as follows. Firstly, only certain special orbits called discrete orbits of electrons are allowed inside the atom. Secondly, while revolving in these discrete orbits, the electrons do not radiate energy. Now, these points definitely tell us why an atom is so stable. But what exactly are these paths or orbits in which the electrons revolve around the nucleus? Let's understand with an example. Do you know how our solar system is? Yes, it appears somewhat like this. Now here, the sun is stationary at the center while the planets revolve around it. But have you noticed that the planets always revolve in fixed paths? We never find any planet jumping to a different path all of a sudden, right? They always encircle the sun in defined paths. In a similar way, we have the atomic structure. The nucleus acts like the sun located at the center, and the electrons are like planets which revolve in fixed, defined orbitals. These electron orbitals are referred to as shells or energy levels. Now, the name energy levels gets us to an important concept. Niels Bohr suggested that the electrons revolving in these orbitals do not radiate energy. Now, this is justified when we use the term energy levels, because it indicates that each shell has got a defined energy level. That means when the electrons revolve in these shells, they do not liberate any form of energy. And how do we name these shells to indicate their position? It's simple. Beginning from the one near the nucleus, we name them as the K shell, L shell, M shell, N shell, and so on. Yes, K, L, M, N, and so on. And what if we want to number them? In that case, we use the letter N in lowercase and write them as N equals 1, N equals 2, N equals 3, and so on, beginning from the one next to the nucleus. So we can name them alphabetically, or we can even number.
So this thing I have discussed in a very fast class, is it not? So there is a different number of energy levels when we get to know about the electronic configuration. So by which actually we can also write now the electronic configuration, like in case of carbon. So 2 and 4. So in the first cell there will be the maximum number of electrons is 2, and the second cell is maximum number of electrons is 8. So in the when you are writing the electronic configuration of carbon, this is 2, 4. In case of nitrogen, it's 2, 5. In case of oxygen, it will be 2, 6. In case of fluorine, it will be 2 and 7. In case of neon, it will be 2, 8. Are you getting my point?
Yes, sir. Yes, sir.
Okay, so just let me know if there is any confusion, because already these things we have came to know before we have in a very fast class we have discussed.
Number them. With all these theories and points known, do we now know the structure of a typical atom completely? The nucleus contains positive protons and the electrons revolving around in fixed orbitals. Is that how an atom is structured? Not really. We still have one more subatomic particle left. And what and where could it be? Let's find that out. It was around the year 1932 when a famous English physicist, Sir James Chadwick, found the third subatomic particle. He found that the particle had a mass almost equivalent to that of the proton. And what about its charge? Astonishingly, it had no charge. Yes, the particle was neutral. The particle was later named as neutron, denoted by the letter N. Thus, now we have the complete design of an atom. In the center lies the nucleus having positively charged protons and neutral neutrons, while the negatively charged electrons revolve in fixed orbitals around the nucleus. But how exactly are the electrons distributed in the respective orbitals? Is there a way to find out the maximum number of electrons that one orbital can contain? Or is it that the electrons are randomly scattered in the orbitals?
So this thing already we came to know the maximum number of electrons. Can you say the formula by which we can determine the maximum number of electrons? 2n square. Very good. Thank you. Okay. So now let me go through this very easy thing. That is what we came to know from Bohr's postulate. Okay. So let us write down the Bohr's model of an atom. Just a minute. Participant. So let us move this. So now again you need to write with me. Okay. So this is the Bohr's model of an atom. So the first one is the most easy one. An atom is made up of what? Made up of three particles.
Three particles.
Write with me in your copies. That is electrons, protons, and neutrons. Okay. Number two. So I'm just not getting with details because you know the electrons are negatively charged particle and protons are positively charged particles and neutrons are neutral. Okay. The second postulate is that, or the second conclusion you can say, the protons and neutrons are located in a small nucleus at the center of the atom. Number three is that the electrons revolve rapidly around the nucleus in fixed circular pathway. Circular paths called energy levels or cells. Okay, done?
Yes, sir.
Yes, sir.
Good. Number four is that the last point was number three. Okay. So number four, there is a limit to the number of electrons which each energy level or cell, rather you can say, can hold. For example, the first energy level of K cell can hold maximum number of 2 electrons, the second energy level 8, and the third is 18, and the fourth is 32. Next one is each energy level or cell is associated with a fixed amount of energy. And the number 6 is that there is no change in the energy of electrons as they keep revolving in the same energy level. And the atom remains stable. Okay. So the change in the energy of an electron takes place only when it jumps from a lower energy level to a higher energy level, or when it comes down from a higher energy level to a lower energy level. When an electron gains energy, it jumps from a lower energy level to a higher energy level. And when an electron comes down from a higher energy level to a lower energy level, it loses energy. Okay. And the number 5 point is very much important also, that each energy level is associated with a fixed amount of energy. The cell nearest to the nucleus having minimum energy level, and the cell furthest from the nucleus having the maximum energy. Okay. Done?
Yes, sir.
Yes, sir.
Okay, let me go to the next topic. Is that last one? This topic about atomic number. Very easy. So what is that atomic number? The number of protons in one atom element is called atomic number of that element. So simply we can write that atomic number is equal to the number of protons. Is it not?
Yes, sir.
The number of protons of an element. Number of protons in one atom of an element, sorry. And the atomic number of an element is said to be. So what will be the atomic number of carbon? Can you say? 6. Very good. So the atomic number of carbon 6, nitrogen 7, sodium what will be What will
11.
be 11? In other words, can you also say that atomic number of element is nothing but the number of electrons in one neutral atom? Can you say that? Is it not? We can also say the atomic number can be also write as the number of electrons in a neutral atom. Are you getting my point or not?
So please repeat.
Yeah, the atomic number of an element is also said to be the number of electrons in one neutral atom. Why? Can you explain it? See, in the atom, the number of protons and number of electrons are same, is it not?
Yes, sir. Yes, sir. Yes,
So,
sir.
hence the atomic number of an element is said to be the number of protons. Then also we can say that number of electrons in a neutral atom is also said to be an atomic number. Are you getting my point or not? Are you getting my point?
No, sir.
Can you repeat it for once, please?
Yes. What I am saying is that in an atom, so the number of protons in a neutral atom, the number of protons and neutrons are same or not? Same.
Yes, sir.
So if the number of protons and electrons are same in a neutral atom, so can we say that the atomic number of element is the number of protons in an atom that is equal to the number of electrons in a neutral atom? Is it not?
Yes, sir.
Yes, sir.
Okay, so that is the thing. Just I want to make you understand. So the last one. So we came to know about the atomic number is also denoted as Z. So what is the mass number? Mass number of a neutral atom is nothing but the number of protons plus number of neutrons.
Neutrons.
Okay. So this is the thing. Today's class we came to know, and if you know the number of protons, then you can easily calculate the number of any two mass number and number of proton. You can calculate the Newton number, or vice versa. Just the last I want to say that the right way of writing something. Okay, it's like that. We are writing in mass number here. And here we can write the symbol of element, and here we can write the atomic number. It's like carbon 12(6). Is that clear to all?
Yes, sir.
Yes,
sir.
So another example we can write sodium 23(11). So 23 is the mass number and 11 is the atomic number. Okay. Today's class, we are finishing my class today. Is there any confusion?
No, sir.
Okay.
No, sir.
Thank you.
Thank you, sir.